Hello and welcome to another video on adding vectors. We've already talked about this vector here and how to get it from its components and how to break it down to its components. The next step we want to talk about now is what happens when we add another vector to it. Now this vector could be anything. It could be something straight to the right, like so. It could be straight up, like so. Or it could even be at an angle, like so. Whatever it is, we need to go through the same general steps. We're going to look at this one because it's most representative, and then kind of look at how this process works. So let's go ahead and erase these two lines here. Draw this one in again with our angle. So as we discussed previously, when you add vectors, you go tip to tail, and then your resulting vector is from the tail of the farthest, or the starting one, the tip of the last one. So this would be, this black line here, or this black vector here, would be the red vector plus the blue vector. It doesn't matter what order we add them in, we've been over that a few times, but how do we add these vectors? What we need to know is both these vectors. So what we'll typically see is something like this, with an imaginary coordinate system plugged in. This is just the same as if it was right here. We just moved it over to add tip to tail. This would be 9 meters at 65 degrees after going 8 meters at 15 degrees. What I want to know is, where do I end up? How does this add? In order to solve this problem, we need to break it into components, add the components together, add the x's to the x's, add the y's to the y's, and then recombine it into a single vector. So let's take a look at this and break it into parts. We're going to break the red into parts using sine and cosine. And we're going to break the blue into parts using sine and cosine. So let's go ahead and just label these x, y, x, y. So all we need to do is do everything we were doing in the last video twice, or however many times we have the vectors. So for the red, x is going to be cosine. Y is going to be sine in this particular case. So that's how I'll set that up. And then blue would be, now you'll notice that I'm breaking this up as if it was at the origin. Because vectors can be added in any order, I could break them up in really any order and treat everything as if it's at the origin before adding them together. Mathematically, we can do it as just each individual vector breaking it up, and that way we don't have to worry about, okay, redraw the coordinate system, how far over it. Just break it up as if it was its own vector and thus its own triangle, starting from the origin. We're going to go through these, break these all up. So red x equals 8 cosine 15. Red y is 8 sine 15. Blue x is going to be 9 cosine 65. Blue y is going to be 9 sine 65. Plug these all into your calculator. Once you've got the individual components, now we need to add. We're looking for this black vector, which would be this entire thing, which is simply red plus blue in the x direction, or red x plus blue x y, and red y and blue y tall. Total in the x direction is just going to be all your parts in the x, red plus blue. So 7.73 plus 3.80. I would personally recommend adding the values in your calculator and rounding those. as opposed to rounding here and then rounding again after. Just round once, make your life easy. So my total in the x is going to be 11.53 meters. My total in the y is going to be 10.23 meters. So this entire thing here and here is 11.53, 10.23. Let's just put that in. So once you have these, all the process is, well, we went this far right, this far up. It's just like adding vectors the first time we did. Okay, we only have x and y. Just add them together. How long is it? Well, a squared plus b squared equals c squared. What angle is it at? Tan angle equals 10.23 over 11.53. You'll notice I didn't write the units here because it's going to be meters over meters. Meters over meters will just cancel out to be no unit. One thing to keep in mind. So now that we've got this all set up, plug in your numbers, give it a try. If you've gone through and done your math properly, you should get C is 15.541 meters long, and it's at an angle of 41.58 degrees, which we can report any number of ways. We've been over most of them, but just for completion's sake, this could be 15.41 meters at 41.58 degrees clockwise, or at 41.58 degrees north of east, or at 48.42 degrees east of north, which is the same as bearing 48.42. All these are perfectly viable options. So this is how we add. We take our vectors, we break them into our components, we add the components together, and then we go through and do the math for the combined components. Pretty easy. There's just one complication we need to talk about. So here we've got two vectors once again. We've got this red vector going up at a 40-degree angle north of east for 10 meters per second. We can add any two vectors as long as they're the same vector. Meters per second can add to meters per second, but it can't add to meters. Helpfulness of this will be outlined in your homework a bit more. And then we have 5 meters per second south. A way you could be talking about this is if your boat is sailing across a river or a plane, whatever you want to talk about. You're trying to go in this way, 10 meters per second at a degree of 42nd, but the river is moving down south, like the Fox pretty much does, at 5 meters per second. How fast are you actually going? What's the angle you're actually going at? The problem here is that this is going up, this is going down. And if we add them, how we just did, it won't quite work out. So let's break these into components really quick and take a look. Red is standard. Red is pretty easy. Cosine of 40 equals x over 10. Sine of 40 equals y over 10, which means x equals 10 cosine 40. Y equals 10 sine 40. As for the blue vector, which is 5 meters per second south, there's no x, there's no left, right. So x equals 0. Because it doesn't move left, right at all, or my x component is just 0. If it had this been just here, no problem. Y is the slightly trickier part. Y is still going to equal 5. But because red is going up and blue is going down, they're going in opposite directions. And in opposite directions for vectors means opposite signs. Now, by convention, we say up is positive, down is negative. We say right is positive, left is negative. But really, that's just a matter of convention. You can define anything to be however you want. You can say this is positive, this is negative, this is positive, this is negative. Or flip it, positive, negative, positive, negative. Whatever works best for you. It is often easier when you're learning this to stick to the standard convention and talk about varying later down the road. As long as you're consistent in your problem with which way is positive, which way is negative, the math will work out. Anyways, back on topic. Because these are going opposite directions, red is up, blue is down, what we will do is we will call this negative 5. So now go through to your sines, your cosines. 10 cosine 40, 10 sine 40, which are 7.66 meters per second and 6.42 meters per second, respectively. Once you've got those, it's the same process. Add them together. Adding a negative number is the same as subtracting. Finding the components of this black vector triangle here, and then go through the process. What's the angle using tangent? What's the length using Pythagorean theorem? So let's go ahead and do that. You'll notice that x is 7.66 because 7.66 plus 0. 6.42 minus 5, however, gives me 1.42. And from here, I go over to the Pythagorean theorem. And tangent. Plug in your numbers, solve. So if you've done all your math, you should get 7.79 meters per second at 10.50 degrees. So actually, you're not even going your full 10 meters per second that you could be going, or you would be going if the water was perfectly still. And the angle you end up going at is here. It makes it, this is important for like river crossings or airplanes, which is what you'll see a lot of in your homework. Make sure you report your answer fully. So 7.79 meters per second at 10.50 degrees north of east. One answer is good. You don't need to give me all 4. I'm going to stick to the simple one because we're using north, east, southwest, and it's the quickest one to find. Typically, that's what I'll do and what most people expect you to do. If you ask for a specific measure, use that. I'm going to put one more on the board, have you do it on your own, and then check your answer. Okay, on the board you have your problem. We have 2 vectors. For this time depicting someone taking a walk. First vector is walking 30 degrees south of west for 12 meters, and then pivoting and walking 80 degrees north of west, or 10 degrees west of north, take your pick, for 7 meters. How far are they from their starting point? What's their displacement? Is ultimately what we're going to end up asking here. And at what angle is their displacement? To rephrase it and think about this, why this would actually matter. Once they're here, my friend wants to come over and talk to them. How far and what angle does their friend need to walk at? Go ahead, give it a try. Check back after the class. Okay, let's take this one from the top. The blue and red vectors break down like such. Once you add them together, you get negative 11.61 meters and positive 0.89. The reason this is negative because I use the standard system. I said down and left were negative, up and right were positive. You'll notice that the calculator didn't give me negative numbers. Probably didn't give you negative numbers either. That's because I'm using the reference angle, not the mathematical angle. Had I used the mathematical angle, the numbers would have popped out negative already. All solved for me, no problem. But that requires an extra degree of complication that most people don't want to get into. Regardless, you'll have to send the signs yourself just based on looking at the image that you've drawn. From here, you get these two values. We're barely above the x-axis here, so it's actually closer to here than here. But I was guesstimating when I drew it, so that's okay. Once you've got that, you plug it in over here, you get 11.64 meters, and you get a negative 4.38 degrees if you plug in the negative sign here. And that's the thing that we should probably talk about. Negative 4.38 degrees indicates that it's going down. It's going to be here. Because whenever you plug it into your calculator, you're getting math degrees out. Now, if you just plugged in the numbers, you ignored the negative here, you would get 4.38, and that's the angle here. Arctangent, inverse tangent, only goes between here and here. It's only these two quadrants. Anything that comes up over here, you have to add 180 degrees to. So if you add 180 degrees, you'll get this angle here, which, if we were reporting in math degrees, would be really helpful, which would be 175.62 degrees, counterclockwise. Or, because we can use logic, and think about this for a second, adding 180 gives us a straight line. This angle and this angle will be the same. So this is 4.38. This is also 4.38. Either way, how you think about it, either way you get there, it works out. Long story short, this angle is 4.38, and the length of this is 11.64. So the net displacement, the way the front has to travel, is 11.64 meters at an angle of 4.38 degrees north of west. Again, we can translate that to any number of other systems. We could say it is bearing 274.38. We could say that it's 175.62 degrees counterclockwise. Any of these work. If you got this, awesome. If not, ask questions.